Brian, you ready to drive us for the first part?
Yes, I can share my screen. Can you all see that?
Yep.
Cool. Yeah, so I guess the context is,
Brian, could you zoom in a little bit?
yes, let me try to do that.
You can also just make the window smaller.
How is
like
that?
get rid of the labels
Great.
sidebar, which is useless.
Yeah, there we go. Okay, so the context is we want to be able to compile tensor subclasses as part of torch.compile. And so there's this existing repo called TorchQuant, which is a torch dispatch tensor subclass, and it implements quantization. And it basically, like, I'm not the main person who works on it, so other people can definitely speak to it better than me. Christian and a bunch of other people have been working on it, but it's a torch dispatch subclass that basically like inserts quantize and dequantize related ops into the graph anytime you call an operator, and then has a Triton kernel for like a fast int8 macl. And I was just kind of like hacking on a prototype to get some version of AOT dispatch working that like works end to end with TorchQuant. And I won't show like a ton of details in this prototype, but like the high level thing is that here's this benchmark script where you have a model FFN and you like manually change some of its weights to be these QTensor subclasses. And then you torch.compile the whole model, and then like it just works, which is pretty cool. Except it doesn't really fully work because so if you see I'm doing all these like detached calls here, and in the current state today, actually, the main thing that breaks is functionalization. And the state on master today is that in AOT autograd, functionalization only runs when at least one of the inputs to your graph requires gradients. And so I'm doing this kind of hack where I force all of the inputs to not require gradients, and then I skip functionalization, and then the whole thing compiles. So I think the two main things that I wanted to talk about are like, one is the kind of API design for what's the right way to kind of, if you're a tensor subclass, to tell like the PT2 system that you are capable of being compiled. And the other is like how to get functionalization working properly. So any questions so far? I see a hand raised.
Yeah, I have one question because I'm not sure if using QTensor is a good example. Because as I talked to Razel, Kimish, and Jerry, we're working on the neo quantization flow. And I think the AO team has a plan to, after the neo quantization flow is there, has a plan to deprecate the QTensor. So yeah, it's great that to discuss the subclass in general, but I'm just wondering if the QTensor is a good example in the long term.
Okay, was not aware of that. I mean, I guess maybe there should be a different subclass that I prototype with them. But I guess the idea is this should be like relatively agnostic to the specific subclass.
Actually,
or like the main like got it.
Sorry, I'm going to interrupt. I want to push on this a little. Do we have enough folks from quantization here today?
Yeah, I'm pinging Jerry and Kimish.
Okay, so I'm going to propose we halt this segment for now and talk about the do you think having quantization talk about the new plans like beyond QTensor would make sense for this venue? Because
sorry, can we just
yes.
Sorry, can we just repeat one more time? Like what's the holdup? What's the issue with this here? So this is on the roadmap for AO quantization. Like that is something that is absolutely going to be potentially in core with 2.1, and yeah.
Yeah, I think you might need to verify with the AO team to confirm. From my side, like for the QTensor, it's in the long-term quantization plan to not use QTensor in the quantization flow.
What does it mean? Like not use QTensor in the quantization flow, as in you want a workflow that doesn't use QTensor, or?
Yeah, there will be a flow that does not use QTensor, but use general tensor with corresponding D types. Kimish is there. Maybe he can add
So all the
something.
quantization we currently have in core is on CPU. QTensor specifically looks at GPU quantization, int8 based GPU quantization. That's one thing. And then all the workflows we currently have don't use QTensor as a tensor subclass. They use the C++ subclass QTensor, right? That's already landed in core. So
Okay.
Like-
Kimish, do you have any input from the GPU side for the new quantization flow?
You're asking me?
Yeah.
So I didn't follow I just joined, right? So I didn't follow what was the conversation before
Okay,
that.
so for context, Brian was going to present the work he's done on the Torch Quant repo, and specifically the Python subclass QTensor, on making this integrate well with the PyTorch 2 stack so that you can compile through it. However, it emerged that apparently QTensor is long-term deprecated and not going to be what the quantization flow is going
sorry,
to use.
there are two different QTensors here. There's the QTensor that's in core, that's a C++ tensor input subclass. And then there is this tensor subclass here written in Python that happens to be named QTensor. It could be named anything else that you want.
And this is both of these are separate from the quantized tensor that exists in the
Correct.
So for clarity, there isn't actually a thing called QTensor in core, right? Like there's a QTensor impl, which is the tensor impl subclass, but generally we don't refer to it as QTensor in core unless I'm mistaken. I guess people do refer to it as QTensor. Anyway, so is this just a terminological confusion?
This is just terminological confusion. In fact, if you go to the fair internal repository here, the TorchCon repository, and you just show people, whoever's controlling the screen, what actually QTensor is, you'll see it's a very, very simple tensor subclass. And, you know, it's something that really should work. Like all you're doing is you're saying, let's construct a tensor that has the same D type and everything as the original tensor, except it uses a different internal storage.
So in the trace, in the trace, you would never see like a QTensor, right? It is like all.
You would not. No, you would trace
yeah.
through this, and you would see dynamic. This is the thing; it's fully dynamic. So you would see the injection of quantized and dequantized routines.
I see.
And then a call to a to an int8 matmul and all these kind of things.
So I also imagine that this has very little to do with the quantization flow per se, right?
Yeah, this is out of tree. This is not part of the workflow that's currently in core or anything like that. Right. This works primarily for large matrix multiply cases because you have the dynamic quantization overhead.
Yeah.
And I think it's a really great example of a tensor subclass because it is so simple. Like literally you just replace an instance of a tensor with an instance of this subclass and everything else stays the same. The result is a regular tensor from the matmul as well. So it's kind of like the simplest way in which you can do quantization. Yeah, so that's basically like you are just modifying internal storage to I guess like store if at all. Otherwise, you're just dynamically quantizing, let's say, both parameters of the matmul like A and B, and then just exactly.
Okay, got it.
Yeah, it's just the parameters are being replaced by, instead of being an FP16 tensor, it is now a triplet. Like an int8 weight, some scales, and some offsets.
Yeah.
Okay, so before we head back, I just want to confirm. So Christian has stated that the deprecation from quantization is the C++ QTensor impl, which is consistent with what I thought the POR was. Kamish, is this correct?
I think it's a quantized tensor, right? I actually don't know about the QTensor per se, but the one we have had a quantized CPU dispatch key associated with a quantized tensor.
Yeah, that's the thing that has a quantized CPU dispatch key. In C++ code, it's QTensor impl. And
yes.
We don't usually call it QTensor in the code base. There's a few references to it as QTensor, but it's usually not called QTensor.
Yeah.
A spoonful of scuba, hand?
Oh, yeah, sorry. Yeah, I should lower the same question.
Okay, so that makes sense for y'all as well. Is that right?
Yeah. So just to summarize that, the QTensor, like the plan for quantization is to not have a separate concept for quantized tensor, but decompose that into different D-type tensors where whatever the parameters that the QTensor today assumes, like scale 0 point per channel, blah blah blah. All of that will
Okay.
become explicit.
For clarity, I'm going to propose that we refer to the torch quant QTensor as Python QTensor or torch quant QTensor, and I think that'll be good enough. Okay, Brian, after this 10-minute segue, I think we can get back to your original presentation plan.
Sounds good. Yeah, and I probably should have just clarified, like, what is the goal that AOT dispatch is trying to solve? And it's basically like for Python tensor subclasses that are able to translate ops into operations on dense tensors, then we would like to compile a graph where like the final graph that we see is a graph that only knows about dense tensors. And so we want to sort of trace through this mapping from tensor subclass to dense tensor and just get out a giant graph of operations on dense tensors. And so yeah, there's sort of this prototype. It like sort of works today, but is like very fundamentally broken in certain ways. And kind of the two main problems I wanted to talk to people about are
actually, Brian, before you talk about the problems, can you outline to us how the prototype is supposed to work in principle?
Yeah, it's a good idea. So I'll compare the like normal AOT autograd workflow with the like general AOT dispatch workflow. And sort of the like translation steps are we start out with a function on like a user program on the Torch API that can handle tensor subclasses in some way. So we have Torch program on subclasses is what we start with. Or sorry, let me start with the non-subclass case. The normal AOT autograd is we have a Torch program on normal tensors. And then first Dynamo captures that, and then we translate that into an A10 program on tensors, and then functionalization runs, and now we have functionalized A10, and then our decompositions run, so we have functionalized plus lowered A10, and then finally we send this graph that is like functionalized, decomposed A10 ops to a compiler. And there's no tensor subclasses here, and everything's on dense tensors. And then the sort of AOT dispatch version of the above thing would be we replace the initial tensors with tensor subclasses. And at some point, we trace away the tensor subclasses into ordinary dense tensors. And so we start with a Torch program on subclasses. We turn that into an A10 program also on subclasses. And then the step where the like subclass to dense tensor translation happens is before functionalization. And so the full set of steps is like Torch program on subclasses. We lower Torch to A10, that is still non-functional. Then we trace through the tensor subclass, and then what that will end up doing is like we trace through the Torch dispatch calls, and we end up with a new set of operations on dense tensors, and then we functionalize that program and run any decoms. And so this is kind of where the like AOT dispatch step slots into that whole sequence of operations. And one reason for this go ahead.
I want to interrupt for a moment, and I just want to point out that although this is presented as a pipeline where you have a graph and then you get a new graph and so forth, for many of these steps, we never actually materialize a graph, right? So for example, in the original step, you get a Torch program on tensors from Dynamo, and then you go straight to functionalize and lowered A10. So you never actually materialize an A10 program on tensors or a functionalized A10.
Yes, that is totally right. So any questions about this kind of like ordering of operations? Okay, so Ed, does it sound good if I just go over these two problems first, and then we can just talk about them in whatever order?
I just want to quickly see if there are any other questions on the room about how this is supposed to work. Yeah, Driss.
Sorry. Although you don't get a graph with the intermediaries, is this still the order in which the final graph is produced?
Is this still the order the final graph is produced?
Yeah, like
Yeah.
you're not going to get an A10 program, or you're not going to get an A10 program on tensors, then a functionalized A10, but like and then a functionalized and lowered. I'm assuming you're going to go to the last one in one step, but in the unit of work that creates the final program, does it first make an A10 program on tensors, then functionalizes it, and then lowers it, and that's the one graph you get?
That's right, yeah. And the way I kind of think about that is each of these steps is sort of like a decomposition. Like functionalized A10 will convert like matmul underscore into matmul. And then functionalized plus lowered A10 will convert functional matmul into like plus some other ops. And sort of the ordering that these decoms run is specified by this ordering.
Okay, cool.
Okay, let's keep going.
Cool. Okay. So one question is sort of like we have a tensor subclass, and by default we try to run it with this AOT dispatch code, and it breaks. And the reason it breaks is because if you're a tensor subclass, you need to like do some things to tell the system like how to properly get traced. And like what that really means is just we're like tracing operations on subclasses into operations on dense tensors. And so somehow like the PT2 system or AOT autograd needs to know how to convert between subclasses and dense tensors. And like there's a couple ways to expose that, and like it's just sort of a question of like how we want to do that. So there was already some discussion in the chat, but like one option is PyTrees. We could also not do PyTrees, and there's kind of trade-offs to both of those things. The prototype. So originally I prototyped it without PyTrees. Then I tried patching it in to use PyTrees instead. And I think like one of the major trade-offs is just PyTrees like let you do more for free, so it's less boilerplatey. But it's also like very implicit. And so there are cases where you like, given like a list of tensor subclasses, there are cases where you want to like PyTree through all of that into a bunch of tensors where you don't care about the subclass and you want to kind of like PyTree through the subclass. And there's other cases where you don't want to PyTree through the subclass and you kind of want to treat the subclass as leads. And so like one kind of weird thing about doing everything with PyTrees is that we need some way to deal with both those situations. And PyTrees don't have like an API to do that today.
Okay, I have a comment, which is actually I want to go back to the lowering graphs we wrote, because I think we need to include autograd in the discussion here, because in particular, if QTensor didn't care about being differentiated, then they probably could have just done a torch function subclass, right? And like there must be a reason why they want to go to an A10 program on subclasses instead of going from a torch program on subclasses to a torch program on dense tensors and then doing the normal flow. Albin.
Unless Christian wants to answer that, but otherwise I have a quick answer. The actual quantized D type might not be continuous. So you want the autograd to run at the floating point precision level. So before you actually open things up into whatever is the actual D type you do the computation in.
Right. So what I'm saying is that there should be in this graph, in this flowchart, a step which is when we do autograd. And I believe it's before A10 program on subclasses.
Yeah, you just kind of want autograd to run.
No,
normally.
I don't. I think that's the wrong place.
What do you mean?
I don't think we generate the backward graph after we've lowered it to a program on dense tensors.
Oh, no,
Because as
before.
Alvin said, once you lower to dense tensors, they're going to be like what, int8 tensors or something? You can't even.
Yeah, that's what I was about to say, is that you just want autograd to run as it would on a regular tensor, except it's using the instances of.
I don't think it's here either.
Okay.
I think it's before A10 program on subclasses, because A10 program on subclasses is the point at which we actually do the lowering to dense tensors, right? So we should have taken care of autograd at that point.
So what I mean by the distinction here is just, or maybe I don't understand. I think.
Well, so really, I think it would be clearer if we were labeling the arrows, right? So going in order, the first arrow is the arrow that, I mean, what does it do? It's running makeFX tracing and tracing out a bunch of, like, if we were actually materializing things, it would stop and trace before we actually hit the torch dispatch handler on QTensor. So that's what the first arrow is.
Sure. I guess in my head, these also kind of map to dispatch keys. Like this is sort of, we're hitting before decomp, so like composite implicit autograd.
So when you're at the A10 program on subclasses, going to the dense tensors, that's the Python key, right? And therefore the autograd key runs before the Python key. Would you like me to try editing?
Yeah.
Okay, let me yank. Let me yank the screen share as well. While we're flipping this over, are there other questions from the room? So specifically, is this big enough for everyone? Let's just do this as a numbered list. To end up with a program on subclasses, you need to hit the Python key. Actually, yeah.
No.
Yeah, no, that's not right. So you run the Python key on QTensor, and that's what gives you the A10 program on dense tensors. And then when you run the functionalize key on dense tensor, that gives you functionalize A10. And then running the Python key on proxy tensor mode is what lets you apply the proxy tensor decompositions. So the claim I'm making is that, well, it's kind of weird to put it this way, but it's something like, well, really I just want an arrow. I don't even know what to call this thing. But there's an arrow, which is the autograd key on QTensor. Brian, does this make sense?
Yeah, I agree with this.
Albin.
Why is functionalization below the decomposition?
Excellent question. So this is Brian's number 2, which is functionalization interaction is broken. But Brian, do you wanna answer this?
Yeah. So like, I guess first we should say, why should it be there? And then also, why is that a problem? So why should it be there is just like, so autograd will run before the subclass's torch dispatch runs, which is expected, and that's what we want. And then there's this question, like, should functionalization also run before we go to the subclass, or should it run underneath the subclass? And the answer is it should probably run underneath the subclass. And like, the reason is that feels right, just because the subclass could do anything. So if the subclass redispatches to an in-place operation, then we want to functionalize that. And so like the functionalization should definitely run underneath the subclass, and then it would be redundant to have it additionally run above the subclass. And that is sort of like why we're in the situation of autograd should run above the subclass and functionalization should run below the subclass. And that is what causes us to hit some problems.
Alvin?
Sorry, I didn't lower my hand.
Okay. Brian, do you want to explain the proposed solution? Do you want the share now, or?
You can just go to the bottom.
Okay.
So I think Alvin already like gave one proposal, and I think there's a couple options, but that one probably feels like the easiest. So like, the problem has to do with our fixed dispatch key ordering, where we sort of have like, there was a really good description of this like a year ago, I think, when Alvin and Richard were first adding the stashing TLS logic in the dispatcher. But the problem is basically we have like multiple layers of tensors. We have the outer subclass and we have the inner dense tensor. And you can have a bunch of dispatch keys like attached to the tensor in both cases. And the sort of default state of the system is that all functionality keys that are enabled will like always run on the top level subclass and not on the sort of like inner subclass. And for the most part, that's always been fine. And in this specific example, we sort of need to very carefully arrange for functionalization not to run on that outer subclass, but to instead run on the inner class, on the inner tensor. And so the sort of bad thing that'll happen by default today is that functionalization will just run on the subclass instead of underneath. And so I think there's like a couple options that were like already discussed in the chat, but I tried to lay out the main ones above. So one is Alvin's example from the subclass zoo, basically like inserting an extra layer of wrapping and kind of mucking with TLS to kind of just force the state of our dispatch keys to be correct sort of in both cases, like make sure functionalization is excluded at the wrapper level and then included underneath. Another sort of like more complicated way to fix this that could also potentially be cleaner is figuring out a way for functionalization to act as a Python mode. Where like one thing that feels kind of nice about that is we already have these two other, like we have all these modes that run like fake mode and proxy mode. And you can imagine a version of functionalization that is a mode where just the ordering is that functionalization mode runs, then proxy mode, then fake mode. And they all run underneath the subclass and everything just kind of works properly. There are a bunch of things that make this complicated, mainly just like functionalization not being a Python mode today. And so you can imagine like rewriting it as a Python mode or figuring out some way to like kind of take over the existing functionalization logic and like have it work with modes.
I want to try to explain in more detail how these two proposals work and contrast them. So the first proposal, which is adding an extra layer of wrapping, what I'm going to do is I'm going to take this ordering and I'm going to modify it so that it makes sense. So you can see that the traditional dispatch key order is autograd key, functionalization key, Python key. So what you want to do whenever you do extra layers of wrapping is you essentially get to copy paste the dispatch order as many times as you want. This is the trick that PyTorch does, by the way, so that it can call autograd multiple times. So essentially you have an outer tensor, and on the outer tensor you get to do autograd functionalization Python key, and then in the Python key you go ahead and you unwrap to an inner tensor, and then you re-entrantly run dispatch again, where you get to do the same set of keys on the inner tensor. And so basically, if you do this as many times as you want, you gotta have as many copies or reorder the dispatch keys as many times as you want. So concretely, the proposal would be you run the autograd key on QTensor as before. You don't run the functionalization key here, so functionalization is disabled at this point. And then you run the Python key on QTensor, which does the actual desugaring. And then at that point, you somehow unwrap, and now you're on the inner tensor object, and that's going to be a functional tensor wrapper. So you skip the, hang on, this is in the way. you skip the autograd key this time because you've already done autograd. There's nothing else to do. And you do functionalization, just the normal functionalization. And then you do the proxy tensor. And so that's how proposal 1 works. Questions about this? Okay, let's contrast this with the second proposal, which is convert to Python mode somehow. So the way this proposal works is we don't do this business of having multiple copies of the keys. And instead, we run the autograd key on QTensor. We don't run functionalization because it's too early to run it. And then we run the Python key. And this time the Python key has to have a bunch of things. We need to run Python key on QTensor, Python key on Python functionalization, and then Python key on proxy tensor mode. Where you can see sort of that if you basically have a functionalization mode, you can just sort of put it onto the mode stack. And the order the mode stack runs is we first handle the subclass. QTensor does not have a mode, and I don't think they want a mode. And then you just say that functionalization mode runs before proxy tensor mode. Questions about this version? Opinions about which one feels better?
I have a question.
Yes, Christian.
So QTensor no mode. I mean, you can add a mode to QTensor. No.
We can add a mode to QTensor. Yes.
Like it's
Do you want a mode though? Like, isn't the current kind of ordering of operations that the inputs aren't quantized, but the weights are, and you don't want everything to be quantized?
yes. So a mode would force us to quantize everything, including the activations, aka the results from the operations.
I think it would at least make it more difficult.
Well, I mean, you can always install a mode and have it do nothing unless it sees a subclass in question. But typically you set up a mode because you want to do something different for all operations. It's kind of wasteful if you don't need to do something different for all operations because you're still getting the callback for every function call. So that's why fake tensor mode exists, right? Because fake tensor wants to interpose on every single operation to fakeify it.
I'll put it this way, like, since QTensor is, since I'm on the same team as as you guys, I don't mind us making those changes because it's easier to change something out of tree than in tree. But I think this is an example of like a very simple tensor subclass that's like very attractive for the community in general. So another question is also like, is that the user experience we want people to have? Well, let me ask a different question first. If we added a mode to QTensor, could we fix this? Would it be done?
No, because which proposal are you talking about?
The second one.
So in the second proposal, QTensor being a mode or not actually doesn't matter. The sort of thing that Brian stated was complicated was making a Python functionalization mode.
Okay.
Brian, can you explain a little bit more about why it's complicated?
Yeah, to be fair, I haven't like carefully stared at what this would take. But I think like the two options are either option one is rewrite all functionalization in Python just natively as a mode, which is like an awesome end state to be in, but would take a lot of work. And option two is like figure out a way to write some kind of shim Python mode that actually just calls into all the existing C++ infra. One thing that makes this a little, at least off the top of my head, one thing that would make this a little hard is we already have this notion of functionalization as a dispatch key, and somehow we would need to make all of that. We'd sort of need to co-opt it into being like the Python key instead to work as a Python mode, and it's a little hard to say how hard that would be. But that's not the way the system's intended to run. So I could imagine hitting weird problems.
Right, but this is sort of this is where the proposals are actually not all that different, because let's say you wanted, okay, well, so the point of Albin's prototype, and Albin couldn't make it for the second half of this meeting, so I'm going to have to stand in for him. The point of the this functionalization prototype is to basically show that, hey, in PyTorch, we wanted to run grad multiple times. But how do you run grad multiple times? There's only one autograd dispatch key, and you don't you don't get multiple copies of it. So what do? Well, you do the wrapping thing, right? So so this is done with using a tensor subclass rather than a mode, but you can do it with a mode instead. You do the grad at one level, and then you enable reentrant dispatch, and then you do the grad at the next level. So essentially, the general recipe for I have a C++. The general recipe, if you have a C++ mode and you want it to be runnable on its own in Python, so you can, e.g., run it multiple times or reorder it, is to do the PyTorch thing with wrapping, so that you get your own copy of the dispatch key stack. Okay, it feels like we have lost the room. So if there aren't any more questions, okay, Sherlock, go ahead.
I want to ask about the assumption here. So at the very beginning, we say the assumption here is we want to trace everything in one go. That's why all this ordering is, you need to design this very carefully. I'm very naive and just asking what if we can allow this to be traced multiple times? For example, a very naive implementation is okay, on the first trace, I'm just gonna get my simple program semantic, meaning that you can run autograd and functionalization, and everything is just still on dense tensor, and you capture the program semantic faithfully. And on the second trace, where you're passing the QTensor, but the trace is happening on the previous A10 program. And then on the second trace, you basically unpacked all these quantized operations. So in a sense, I don't know how to order this in terms of the key ordering if we were to do this in one trace. But somehow I feel that this is saying, okay, we need to run autograph functionalization, all that thing to get a graph. And then somehow on that graph, you run Python key on QTensor so that it got expanded.
Vaz. You're muted, Vaz.
Yeah, hey, sorry. So we talked a bit about, at least on the Python side, keys for modes and modes for keys. Do you remember that potentially? There's a lot of to-dos actually in ops.py, especially on the py-op impl, where we do a bunch of key stuff, and the to-dos say basically hey, wouldn't it be cool if we could blend modes into this? And some of these things potentially feel would benefit from the combination of the two. I know we're sort of hinting at that. I think there was somewhere earlier that Alden said that it might be nice, but yeah, Python key on proxy tensor mode. Maybe it's time to just design a general system of saying, I'm not just dispatched in a key, I'm in a key under this mode, or inverse, when I'm in a mode, here's the key I'm running on. I don't know what folks think about like a more general sort of system like that.
Okay, this is an excellent segue to the second topic that I wanted to talk about, which is precisely tackling this question. And although I do not have a document written for this, I have most of the design, which I'm going to spell out for us right now. Okay, so the question that Sherlock raised was, what if we just were able to trace out the graph instead of doing everything all in one go? And the question Vaz raised was, what if we could put Python modes anywhere on the dispatch key stack? So to answer these two questions, I want to step away from Torch Quant for a moment and look at a simpler situation, which is how can we trace a model before running AutoGrad on it? So this is, oh, Sherlock, is your hand raised?
Oh, no.
Okay. So this is something that Sherlock is very well familiar with because Sherlock attempted to do this last year and there were reasons it didn't work. But the essential pitch for what you want to do here is today, let's just go back here for a second. You have to, proxy tensor tracing only ever happens in Python key. And by the time you get there, you've already finished handling all of AutoGrad. Now, in principle, you can try to be like, hey, AutoGrad, please don't do anything and give me a graph that is like as if we hadn't run AutoGrad at all, but this doesn't work very well. And part of the reason this doesn't work very well is because, well, even when you don't have anything that requires grad, AutoGrad is still doing stuff. And we're still like also running things like shallow copy and detach. And so in general, if you run the logic that is below AutoGrad, you are not guaranteed to get a graph that is differentiable. Really, what you want to do is you want to stop at the AutoGrad key layer and trace the calls at that point in time and not run anything below it, because everything below it is assuming, oh, I don't have to worry about AutoGrad, hooray. Does this make sense so far? So why do we want to trace the model before running AutoGrad on it? Well, one reason is a pre-AutoGrad graph of A10 ops is useful. For example, Inductor wants to do pre-AutoGrad optimizations, fusions. These fusions cannot happen after AOT AutoGrad because they also want to change the backwards function, for example, memory efficient dropout. And they also can't easily be done on the fly. Well, Sherlock is asking, well, why do we want to have everything on the fly anyway? But like for fusions, you just can't really easily do that on the fly. So it's really helpful to have a graph. And you can do this directly on the Torch Dynamo graph, which we have said is the sort of input graph to your program. But that's also kind of a pain because the Torch program is all of these torch dot star, calls in the Torch namespace. And it's not normalized at all. And so in fact, Inductor has a normalized IR to sort of try to make the IR more normal. But we have a normalized IR. It's called the Python argument parser and then tracing mechanism. Any questions about this pitch so far? So the reason why Vaz's suggestion of what if we can attach Python modes anywhere is relevant here is, well, today proxy tensor mode has to go to Python key because that's the only place Python key interposition is allowed. But if we could instead say, okay, proxy tensor mode, please run at AutoGrad key instead, you would essentially be able to say, okay, well, normally I am, going from AutoGrad to functionalization to Python, aka proxy tensor mode. And this all has to be done in one go. But if instead I can just say, well, AutoGrad stop proxy tensor mode, Then that gives me a graph, which then later I can, rerun again and just have it go further down the pipeline to, proxy tensor mode again later. Actually, I think when you rerun it, you actually do. So it's like actually more like Python argument parsing to pre-autograd proxy tensor mode. And then you run the rest of everything. Questions?
I guess I just have a performance question of do you think that worrying about trace time performance is sort of orthogonal to this? Even if this makes perf slower, we can sort of figure out ways to improve perf if this is the right thing to do.
Tracing is very slow right now, and adding more traces is going to be bad for compile time perf. I think our current attitude is that we just need to make tracing faster so that it's okay to call it a bunch of times. I think that does that jive with the folks who have been working on perf on the call?
Which part? That it should be faster?
That rather than trying to reduce the number of times we trace our models, we should just make tracing faster so it's okay to call it 5 times or something.
Yeah, I mean, I think the way we've thought about it with Horace, and he can chime in, is there's how much it takes per op, and then how many ops you end up doing in general. And so you can't really change user space ops, but you can decomp less, and you can cache things there, and you can short circuit a lot of stuff. But it seems like we don't want to short circuit building functionality like new modes or new keys or making tracing better just for perf. It should be that we should just build whatever we want, and then we should make our time per op as low as possible, as opposed to saying, okay, well, now we can't have this functionality.
Okay, so concretely, I'm going to put out a proposal for how we're going to do this. So the way we're going to do this is for every dispatch key, we will offer the ability to put a stack of Python modes before it, with the assumption that autograd is the key most people are interested in. We will do this only for Python dispatcher because with Python dispatcher, we can implement this entirely in Python without C++ changes. Evidence that this is true is this prototype that I did, which is a pre-autograd version of only proxy tensor mode that basically says, hey, I can capture the matmul call directly. And the way I did it was entirely in Python, just by hacking up proxy tensor, hacking up the Python dispatcher to go somewhere else. This is very bad. It's not the way it should actually be structured, but it shows that Python dispatcher has enough rope to actually make this possible. And there might need to be some way to disable keys when retracing. So if there was, for example, some pre-autograd step, I don't know, AMP. AMP is actually a great example. So if we trace through AMP, so AMP gets applied before we trace, then when we trace again, we must not apply AMP when we do the second graph trace. And that's it. So you essentially maintain a proxy tensor a mode stack for every dispatch key. And then when you get to a dispatch key, if the mode stack is non-empty, you run those modes first, and then you run the original dispatch key. So just to show what this looks like in the more common case, you hit autograd key, you run the Python mode stack, pre-autograd Python mode stack, which gets you to proxy tensor mode. And then you run regular autograd, and then you run everything else. I think typically functionalization won't be turned on at this point. Eventually you hit Python key, and that'll only hit fake tensor mode. And then when you do the graph again, you do blah, 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 blah. You skip past AMP, and you go straight to autograd. This time there's nothing on the stack, so you just do regular autograd. And then you hit the Python key, and you do proxy tensor mode, and then fake tensor mode. Questions, comments? Does this make sense? Okay, question. Who, no, that's calling people too much, but does this not make sense? And if this doesn't make sense, please ask a question that will help you make this sense.
I'm a little confused about 3B and 4A, where, so we call proxy tensor mode in 3A. Proxy tensor mode, the way it's implemented is it internally redispatches to fake tensor mode, and fake tensor mode is terminal.
Well,
and so
are you talking about how proxy tensor mode works today, or different?
So is the idea that like the modes themselves would have to change as part of this change?
So proxy tensor mode does need a change, but its essential structure stays the same. So the way proxy tensor mode works, right, is that it does a bunch of stuff, and it does a redispatch, which it's with itself disabled. Ordinarily, that redispatch goes straight to fake tensor mode. However, when you have proxy tensor mode as a pre-autograd mode, what that redispatch would go to is not fake tensor mode, but the autograd key. And why the autograd key? Well, it's because, you know, we need to actually run the rest of the actual compute, right? Because we need a tensor to attach proxies to at the end. And what would we have run if this mode hadn't been there? Well, it would have been autograd and then the Python key and whatever's on the Python key stack, which is fake tensor mode. Natalia.
Are we hardcoding the AMP position? Because
AMP is a dispatch key, so yes, it is hard coded. Let's call it the correct name, which is autocast.
what if your pre-autograd tracing and transforms?
Yeah, so if you want a pre-AMP transform, then, well, you would just attach your proxy tensor mode to autocast instead. And that would get you the graph before autocast would happen. And this is why I'm like, I don't want to be like, we're only going to add autograd key mode stack, because you might exactly have questions like that. And it doesn't make the implementation more complicated to just treat dispatch keys uniformly.
Do we want to run autograd twice in this example, or is that just an artifact of the way that it's written? Like in this example, we fully run all the autograd kernels, both in graph 1 and graph 2. And it's just in graph 1, autograd runs underneath proxy tensor, so it doesn't actually show up in the graph.
Yeah, I think you have to, unless anyone has a suggestion for how not to.
Like if the stack could have multiple modes on it, then if you proxy mode and fake mode then can you get away with like fake mode as terminals so you never actually do the redispatches?
But fake tensor mode doesn't know how to, for example, propagate requires gradness.
Right.
One question I had about us doing this is this like more philosophical closer to keys or to modes? And like, is a mode now like still a fake tensor mode, or is there a specific fake tensor autograd mode or whatever? Like, where is it like flattened completely? Is it multiplicative and that you like read a field when you're in the mode? Is it the field you read when you're handling the key? Where like what? Just like really deep in implementation for a second. How are you guys thinking about structuring this?
So concretely, the Python dispatcher will have a map from dispatch key to list of modes.
And okay, and what if that mode isn't on the stack right now?
I don't understand the question, because
Oh.
there is no mode stack, or there is a mode stack, but that mode stack is the Python mapping to the mode stack.
I see. Got it.
Sherlock, you put us in this brain space. What do you think?
I think my observation is the dispatch ordering. So like the reason why we need to introduce another trace is that it's the complexity space in a single trace is too much to adjust that we cannot order this properly. So we have to introduce another trace stack to concatenate them together so that things work properly.
So actually, I think these problems are related, but they're actually not exactly the same, right? So yes, so in the other discussion, we wanted to use our dispatch keys, but we couldn't. So we needed to do some sort of concatenation, or like, make multiple copies of the dispatch key stack so that we could get it in the order we wanted. This is sort of the inverse problem, where it's like we like the ordering, but we want to, be able to put Python stuff into more places in the dispatch key stack than we can right now. So they're very related, but they're actually like, I think, opposites of each other.
So like in each trace, basically you're giving people control on exactly which key to turn on and turn off, and also giving people a place to insert the Python implementation, Python mode.
Yes. In this
And
proposal,
also,
you would be able to put Python implementations wherever you want.
yeah, and also we're saying we allowed multiple trace.
Yes, so proxy tensor mode would want to be generalized so that it could be inserted at any spot for proxy tensor tracing.
But I feel, okay, like this is a way to address the ordering problem in one trace, like, because we couldn't figure out the right ordering, like make things fit in one trace. So, okay, then we say, in one trace, the order is fixed, but there is some room for you to insert Python mode, but we have to introduce another trace. So it gives us the maximum flexibility.
Actually, I think you're right. So in particular, under this proposal, what you can do is to get quantized tensor going, what you just do is we want a QTensor. So I'm going to add another thing for functionalization. Okay, so autograd, functionalization, Python. So all you need to do is you need to put you just put a QTensor mode here, and then you've got the right order. So it's a pre-functionalization mode. So yes, so technically this would also solve that problem. I don't know if we should do it this way or not. Brian, what do you think?
I just got kicked out of my room and just came back.
Okay. The delta here is that hypothetically, if we have this general mechanism, you can just insert QTensor mode into the correct spot. Namely, it is post autograd but pre-functionalization, and then you can do it all in one go.
I see. I get like it was the sort of general version of that. It's sort of like users can write torch function and torch dispatch are the two like interposing points, like at the top and the bottom of the dispatcher. And it's sort of given any user modes that are like torch function or torch dispatch modes, there's exactly like two slots in this table that we can kind of dump the user modes to get the right behavior. Does that seem fair? It's sort of like slot number 2 for QTensor is all torch dispatch modes, and then above everything else is user torch function modes.
Well, certainly torch function mode happens before all of this, but then other user torch dispatch modes would happen at Python typically. Okay, let's talk about this more offline. We are 5 minutes over. Thank you everyone for coming to this Composability Sync. I will be at the PyTorch meetup, so if folks want to talk about it more there, we can certainly talk about it. Okay, see you all next week.
Later.